Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello and welcome back to the first day, third session of the third International Conference on Cyprus Issue, Environmental Challenges and Energy Security. In this session, we will be hosting Professor Dr. Salih Ali Sadek, Professor Dr. Iftikhar Yasin, Professor Dr. Khalil Ibrahim Al-Samarai, and Professor Dr. Nureddin Saidi. To give the first presentation of this session, I would like to invite Professor Dr. Khalil Ibrahim Al-Samarai to deliver his presentation. Hello, Professor.
Okay. Good afternoon to everybody. I thank you, Dr. Mustafa, for presenting us to, for presenting me to this lecture. My lecture is going to take the expected local carbon cycle change in the atmosphere of Tripoli district, the capital of Libya. In fact, we have to, if we are going to speak about the carbon cycle, we have to have a background for the effect or the impacts on this cycle. I took the parameter land use and land cover, which has a more impact on the natural and semi-natural biodiversity damage. Of course, the modification of this land use and land cover may cause the relocation of local population and population growth at the coastal areas. This is in general, of course, and as Tripoli is a city existed on the coast of the Mediterranean. Also an increase of tourism and the climate damage. And as we know, that climate always changing and considered the most severe environmental task that impends the societies and the quality of a human life. Of course, this changing has its effect through scale and speed. Both parameters are affecting the climate change and depends on the extent of greenhouse gas emitted. As we know, we know that there are some gases trapping in the atmosphere. Among these gases are the carbon dioxide. I took the carbon dioxide as an example because I have the impact relate on the environment of Tripoli district. The impact of CO2 emission to global warming, as we know that it is increased. The increasing of the impact due to measuring due to different factors, and we are going to see the contributors for the existing of CO2 gas in the atmosphere. This figure shows us that how the CO2 contributing to the atmosphere, according to Wilburn. It's more than 50% of the greenhouse gases affecting the atmosphere. It has, of course, two sources here mentioned in this figure. Now we know that the CO2 has its effect on the atmosphere of the Tripoli district, and we are looking now for the contributor for this, or from where CO2 coming to form the existence in the atmosphere. We see that many studies show that fossil fuel burning, as an example, industrial processes and forests and changes in the land use. Changing in the land use is the parameter on which we are going to concentrate on. EPA adapted the importance of how concentration of carbon dioxide disturb the carbon cycle. Of course, this importance was mentioned by the NOAA. The concentration, as we know, that it's very seasonally in the atmosphere and is still increasing due to pupils' activities. And these activities, of course, impacting the concentration and let the concentration increase in the atmosphere, which affect local and global climate. The concentration of CO2, since it varies in the atmosphere during the year seasons due to activity also of a plant in the carbon cycle, resulting in the unbalance of this gas in the atmosphere, leading to trapping the heat and then rising the Earth's surface temperature. Now we are going to speak about the materials and methods used in this work. Since we have no actual measurements for the concentration of CO2 in the atmosphere released in the Tripoli district, we considered the indirect relations. So we observed the data about the land use changing during the 1969 to 2005. And also another studies showed that the land use changing in Tripoli from 2001 to 2015. Rising temperature during the 2000 to 2007, and the emission data given by the FAO stat in 2017. The methods used to evaluate or to analyze these data, concentrating on the comparing the changes occurred in land use and in temperature and in emission, and comparing the periods at which these rise occurred. So we see now, this is the picture. This is the picture for the Tripoli district with its administrative boundary. Of course, on which our study takes this as a case one. The analysis in this analysis, the land use and land cover changes, we took the parameter residential land use change. The parameter, why we use this one? We use the land use, residential land use changes because it's emphasized on the valuable residential land use in the city of Tripoli, and it detects the residential changing trends, and it shows us how this residential changing trends occurred in the area of Tripoli city, of course, covering the period on which it's tested since 1969 to 2005. This figure or this picture represent the distribution of the people living, residents in the Tripoli district during the year 1969. It's followed here. It shows us how the expansion occurred due to development of population in the district, and now the area of residential expand, and this picture shows us the time of 1980. The third one here, which shows us that in most of the area now the expansion occurred, and this one reflecting the expansion during the time 2005. Now, these two tables show us something in figures, something, the land use in figures, in numbers. As we see here, the residential land use change in Tripoli. We see here how the local residential places, like the center of the Tripoli, Souq al-Jum'a, Tajura, and all are that these are places, names of places of the district. If we look in 1969, that we took the total of the residents living in the Tripoli districts, it's about 1,127 square kilometers. This figure of the area expanded to or increased to during 2005 to 6,783. In total, if we see here, the total area increased by the residential land use change, we see here the number equal to 14,845 square kilometers, which is nearly the area of the Tripoli districts, which is about 15,000 square kilometer. As if we go back here and see this time, this to 2005, how the residential area occupied most of the district area of the Tripoli. The second studies done by Mahmoud 2017. Now this study took the development of urban areas and the irrigation areas and the forest areas. We see here from this table that the urban areas increased while the irrigated areas and forest areas decreasing to very low values of square kilometers. Of course, this is from 2001 to 2015. The analysis, of course, now we know that the land use was changed, and the changing is very quick, and it has an effect, of course, on the environment of the Tripoli district. What is the causes now? What caused these districts? As we said before, that one of the important factor that affecting the climate change is the people activities. Now the land use is as a product or as a result of people's activities. We see that from this table, how much people are growing from 1973 to 2006. Of course, this results depends on the census done on 1973, 1994, and then 1995, then 2006. 1994 to 2006. We see here that the people living in 1973 about 500,000, whereas 2006 more than 1 million living in the area, and that's what caused the effect of the expansion. Now, referring back to the effect of the people activities, This condition of the land use changing compared with the FAO CO2 emission model predicted for Libya. During 1990 to 2016, the emission curve, this emission curve, show rising values dramatically after 2001. So this is the year 2001, and after that we can see how the curve is behavior. However, we can see also here in 2011 the values is starting to decline, but it is still more than that of the 2001. Tracking, now we come to analyze the temperature in the Tripoli district by tracking the yearly temperature records from 2000 to 2015. We see that the values of the temperature are rising. If we compare these values with the rising here from 2000 to 2016, we see that both emission and heat, or the temperature of the climate, or the temperature, sorry, of the atmosphere, are both rising and coincides in their behavior. Now we come to our conclusion. By comparing these data from land use, which increases the residential area, decreasing the irrigated area, and decreasing the forests in the district within the administrative boundary, we can conclude, of course, now if we compare the emission, and it coincides, as we said, with the temperature rise, we can conclude that the observation of the land use changes and emission and temperature records affect the carbon cycle. And this affects the atmosphere, of course, by the anthropogenic activities. It is expected that carbon inflow to the atmosphere increased, although there is no measure to its concentration, and this comes from the impacts and relics left by the anthropogenic activities, which indicates that the three parameters mentioned are changing during the time the tests, which we are thinking now it is still acting and it has to be changed. Thank you for listening, and I hope I did my best to make the comparison to reach to the results with the questions. I'm ready to answer them. Thank you.
Thank you very much, Professor, for this nice presentation. And now I would like to invite our next speaker, Professor Dr. Nurettin Saidi. Professor?
Yes.
Yes, we are ready for your presentation, Professor.
Yes, thank you. Good evening, everyone. So the title of my presentation is Comparative Assessment of Energy Processing Techniques in Different Geological Environments of Libya. The importance of this title, to be very honest with you, came from my experience in applying remote sensing data and techniques in geological investigations of my country, which is a huge country, as you know. So we have different geological environments. We have different regions with different elevations and things like that. I will go to explain step by step. So the presentation contains study areas, which are three. I will talk about the locations and environments in brief. Then I will go for the objectives and research questions, data used, methodology, and then we will explain one by one. I'll start with the Al Jufra area, which is a desert environment. After that, Terhuna area, which lies on the mountain, and we will end with the Shfara plain or Sahel Shfara, which is bordered by the Mediterranean Sea from the north. And last step would be brief comparison between the applying like various image processing techniques in these study areas, and we will end with a conclusion. So these are the three. Unfortunately, these pictures are animations. They cover the study area totally. But anyhow, El Jufra area, which lies in the around 600 kilometers southeast of Tripoli, the capital city of Libya, it lies mostly in the central part of Libya. It's desert environment, barren of any vegetation, and contains rocks, ranges in age from Upper Cretaceous to the Quaternary. The second study area, which is the Tarhuna area, lies on the Nafusa mountain. The elevations between 300 to 900 meters, and most of the area covered by basalt sheet and phonolite intrusions. The last study area is Ishfara Plain, which I told you already is bordered from the north by Mediterranean Sea and from the south by the scarp of Nafusa mountain. The rocks, as far as I remember, cover the study area from Triassic to Quaternary. So the objectives of this research is evaluating the worthiness of image processing techniques for geological investigations in different geological and environmental settings. I faced such a problem when I started my research. I did my remote sensing applications in geology in Libya. Not all the image processing techniques working well in Libya, but some of them work well in one place, while not in another place. So this idea came to my mind. What about if we make a comparison study between three different geological environmental areas to make sure what kind of image processing we can use in each one? So before we go in this presentation, I would like to identify the image processing. Most probably some of you doesn't know about this. Image processing, which applies on the satellite data, it improving the visual interpretation or the visual appearance of images to a human viewer or the human eye, as well as preparing images for measurement of the features and structures. I did mean here the lineaments, the structure. Some of the questions we're going to answer in this presentation is data integration. What about the ability, capability of data integration to solve some problems in the geological investigations in Libya, as well as the impact of environmental factors. Data used in this research is geological maps, which obtained from the Industrial Research Center in Tripoli here, with the scale of 250,000. Of course, Landsat image, enhanced thematic mapper plus, which has very good archive and it's available free of charge from NASA WEEP. And SAR image, radar or microwave data from European Remote Sensing Satellite 2 with the special resolution 12.5 meters. And I got this data from Bayroni Remote Sensing Center and shuttle radar topography mission, digital elevation models to show the elevations in the study areas with the 90 meter resolution from NASA WEEP. And finally, we had field verification or the ground truthing. As for the methodology, we began with the geometric correction using Universal Transfer Mercator and WGS84. And the major image processing techniques we tested and used in this study is enhancement filters, like the three types, equalization, linear, and special, as well as false color composite, FCC, and principal components analysis, PCA, and intensity hue saturation transformation. And I also used the Tasselkrabbe transformation, ground truthing, as we said initially, and finally data integration using geographic information system. As for Al Jufra area, the data used is enhanced thematic mapper plus, radar data, and SRTM. The image processing tested for this area was contrast stretching, the three types, linear, histogram, and spatial, edge enhancement, intensity hue saturation, FCC, false color composite, like more than 6 bands we use it, and principal components, image ratio, and data fusion. So one slide is missed here. So unfortunately, I cannot show you. I don't know how to do that, but there was an animation here. So I would like to show you by focusing on a small area in Al Jufra region. I would like to show you how we integrated the remote sensing data enhanced thematic mapper plus with the geological map as well as the radar data, and then transfer all of that into vector image to prepare the geological map or lithological map. These are this is the results of our work, the lithological map of Al Jufra area, which uses the fused image and FCC. So the results from Al Jufra area. So the efficiency of histogram equalization applied to the enhanced thematic mapper plus image could indicate the homogeneity of lithology in this area. That leads us to say, using histogram equalization, the homogeneous area is quite good. The second, the intensity hue saturation produced very promising results for detecting lithological units, such as vegetation, sedimentary rocks, and volcanic rocks. This is most probably due to the variations in surface temperature and chemical composition between these units. The third point, the false color composite, I did mean the mid-infrared, near-infrared, and green band, which is visible, band combination was able to differentiate more lithological units, which suggests moisture changes in the study area. The last one, the Al Jufra region is lithology and the dry climate were key factors in getting good results from the SAR image. Because as everyone knows, the SAR data has the ability of penetration. So that was very easy in Al Jufra area because most of it covered by sandy dunes and it's an arid area and dry. We will go to the second study area, which is Terhuna area, lies on the Nafusa mountain. The data used were enhanced thematic mapper plus as well as ERS2, and the image processing were tested are contrast stretching, 3 of them, linear, histogram, and spatial, and false color composite, and image ratio, principal components, and data fusion. So this image shows the data fused radar as well as band ratio from Landsat enhanced thematic mapper plus. So the idea here to enhance the visual interpretation and to test the ability of radar or microwave data to penetrate some layers from the lithological part of the study area. This is the final result of the Terhuna area. So geological interrupted map of the Tarhuna area. The 742 false color composite was able to distinguish between several rock units in the study area. Our reference, of course, the geological map obtained from the Steel Research Center, and the fused image and band ratio images have been not effective in this area, most probably because of the basalt sheet covers most of the area. So the results, Tarhuna area, the contrast of the lithological ions in this area was improved by linear contrast stretching. This is in contrast with the Al-Jufra area. The histogram coalization was the best. So linear contrast stretching can produce the best results in low contrast images, which can be caused by insufficient illumination due to the coverage of volcanic rock. Because most of the area covered by the volcanic rock, the illumination of the image was so bad. 2. The false color composite 742 shows the boundaries between basalt flow, basalt cones, and phonolite intrusions, most likely as a result of the temperature variations in various volcanic rock types in this region. Lastly, quaternary sediments areas show more color variations in the fused image than enhanced thematic mapper plus. This is most probably because of the elevations in the study area. Due to the radar capability, to penetrate layers of sand, some features in the area can be clearly traced. The dense of igneous rocks, on the other hand, causes the fused image useless in the basalt and phonolite regions. So from here, we can say to everyone would like to use radar in the mountain area, don't do. Especially if that area covered by the basalt, it's useless. This is the last study area, Shfara Plain or Sahar Shfara. We used Enhanced Thematic Mapper Plus, Shuttle Radar Topography Mission, and the image processing contrast stretching, the two of them. An oblique view of Enhanced Thematic Mapper images, like overlaying on the shaded relief maps. So you can see the scarp of Nafusa mountain here, and this is the Mediterranean Sea. So this is the result of the lithological map in the Sahl Jfara. The intensity hue saturation method was able to distinguish between 15 rock units in the study area, which are, by the way, the same rock units on the geological map obtained from the Steel Research Center. Principal components method were not effective. And to say the truth, like many questions we cannot answer in this study. For example, why principal components analysis does not work well here in this area? I don't know, most probably the season from where we get the image, and sometimes the dust storms in Libya and things like that. But to be very honest, some questions are still without answers. We hope we can answer them in the near future. The results from Shfara Plain. Of course, Shfara Plain lithological units could be more easily distinguished by the histogram equalization, which may indicate that the region's lithology is largely homogeneous. Edge enhancement filter was useful in identifying the drench pattern in Sahl Jfara. Many drench patterns were easily detectable in the filtered image. This is probably due to the elevations of Sahl Jfara. Lastly, it found that the primary factor in detecting the structure and geomorphology was the horizontal and vertical resolution of the produced digital elevation model. It's much better than 2D satellite images. So, for any researcher would like to study like an area similar to Shfara Plain, we advise him to go for SRTM instead of any 2D satellite image. This is some brief comparison between the image processing techniques in the three different areas. For instance, histogram equalization was very good in the coastal and desert environment, while it's so bad in the mountain area. As for the linear contrast stretching, was good and good to some extent in the mountain and desert area, in the mountain and the coastal area, while it was so bad in the desert area, and so on. So you can read them. The conclusion, the results demonstrate that data integration can overcome the shortcomings and limited capabilities of individual data types in a specific geological environment. So for this reason, one of our outcome from this study that we should use in the comparable areas of Al-Jufra, for instance, ASTO data other than or rather than Landsat. Two, the impact of environmental factors on the data integration is very limited as long as the appropriate data and the processes for the environment of the study area are used. So as long as you use the appropriate data and image processing techniques, you will not face any problems, any environmental problems. Three, in comparable areas of Al-Jufra, applying the intensity hue saturation transformation to aster images rather than Landsat images can produce better results. And finally, the histogram equalization and linear contrast stretching can be more effective than individual filters in the comparable regions of Sahel-Jafara, integrating and fusing the results of slope and shaded relief maps can enhance geological interpretations in such environments. Thank you very much for the kind attention. And if anyone has a question and has no ability to give it now, please send it to my email. Thank you very much.
Thank you very much, Professor Saidi, for your nice presentation. Okay, if there are any questions, we will be directing the questions to you at the end of the session. Our next speaker was supposed to be Professor Salih Ali Sadek, but unfortunately he couldn't be with us. But one of his students, Ms. Mubaraka, is with us. He will be presenting their work together for our audience. Ms. Mubaraka?
Hello.
Hello, we can hear you.
Yes, I can hear you. Thank you for being here with you.
Thank you. Thank you very much for being with us. We are ready when you are, Miss.
Thank you. Today, I will present our study impact that entitled "Impact of Climate Change on Seawater Intrusion in the Northwest Coastal Area in Libya," presented by Mubarak Al-Gariani and Salah Ali Sadiq. Introduction: Libya has experienced progressive seawater intrusion in the coastal aquifer since the 1930s because of its ever-increasing water demand for underground water resource. Tripoli city and its hinterland are located in the coastal region of the Shafara Plain, where agriculture activity generally depends on rainfall and groundwater. In the recent years, this risk of seawater intrusion is continuously treating coastal part of the Shafara Plain that form one of the economically most significant area in the country. Given the rapid development of the Tripoli coastal region in the past decades and the challenge of the climate change, it was necessary to assess the phenomenon of silent water infiltration into the coastal aquifer to open different options for the regional utilization of groundwater resource. In this semi-arid region to avoid the precision of groundwater and the deterioration of groundwater quality. This figure shows the location of the study area. Study area is located in the northern coastal part of the Shfara Plain and forms an almost rectangle area 763 kilometers between the Mediterranean Sea and the cities of Swani and Bingashir in the south. This table shows the aquifer system parameters as well as the average well yields and the total dissolved solids TDS in 1993. It shows groups of techniques of the aquifer and the formation, well yield, transmissions, store activity, and the TDS. The thickness of the aquifers varies from the 125 to 200 meters. Clay layers spurts the aquifer from the Quaternary and the lower Miocene aquifers. The lower Miocene aquifers consists of the sandy limestone and overlays the sandy face of the upper Abu Sheba formation. The Abu Sheba sandstone aquifer is found the northern parts where the Abu Sheba sandstone is overlain by Miocenians. The aquifer is thought to be hydraulically connected with the lower Miocene aquifers. The Azizia limestone aquifer is found in the north of the Alizia fault, and because of it is deep, the aquifer formation reaches a depth of 900 meters in Zara, south of Tripoli. This aquifer shows different transmissive and storage properties, like you see in table 1. The aquifer system in the Shfara Plain is thought to be mainly recharged from precipitation, infiltration, and surface runoff. And seawater introduced. It else okay. In figure 2, we can see chloride concentration in the 1957 and 1957 and 1906. Investigation of the water wells in the Tripoli region reveals that all of the wells pump water from the upper section in Shfara Plain aquifer system. Considering this fact, the simulation study presented here focuses on the upper aquifers, Quaternary, Miocene, Pliocene of the Shfara Plain seawater contamination in the northwest Libya. The Tripoli region in Libya has been exposed to problem of seawater intrusion since the concentration of salt camel. Like we saw in table 1 aquifer system parameters. Since then, the rapid growth of pollution and ever-increasing water demand has elected progressive mitigation of seawater into the coastal aquifer. Noting the early indicator noting the early indicator of seawater intrusion during their investigations in the area in 1957, They observed that most the water walls near the coast started to be contaminated by seawater intrusion at the time. In figure 3, we can see chloride concentration in 1972. Jeffel 1972 obtained a similar distribution for chloride concentration during investigation in 1972. Compression of this figure shows that there is a notable change in the position of indication landward mitigation of seawater in recent years. However, the intrusion effect is more remarkable. High rates of urbanization and increased agriculture and economic activities has required more water to be pumped from the aquifer. This pumping has continually increased the risk of seawater intrusion and deterioration of freshwater quality in the Jafara Plain. Observation during a research project in 1994 showed that 375 milligram per liter chlorine contour has migrated inland, reaching a distance of 10 kilometers from the coast in Gilgamesh and in Zara regions, like figures 5. As a simple comparison of these figures clarifies that seawater contamination in the Jafara Plain has inevitably electrified in recent years, and that the problem will most likely become very critical in the near future. In order to make a proper definition of the intrusion, field research was undertaken and water samples were collected from water wells located along select sea to land profiles. A network of 83 wells, 44 irrigation, and 36 domestic water wells was established to record water level and to provide samples for chemical analysis, like the results shows in figure 6. The samples were analyzed for their physical water levels, pH, and electric conductivity and chemical properties, measure anions and cations, and they were integrated together with the historic data to determine the deterioration level in the region and to form background for assessment study. In this figure, table 2 shows a complete data set for the physical and chemical properties of the water samples collected during the field research. In August 1994, water level recording were integrated to envisage temporal and spatial variation, and the results are shown in figure 7, 8, 9, and 10 figures. As we will see in this figures, we can see the seawater intrusion area in study area since 1957, and in these figures we can see how to increase seawater intrusion area in the same area we studied since 1972. And this figure we can see how to more increase seawater intrusion in the 1997. In 1994, we can see seawater intrusion covered all study area. As we know, remote sensing can be used to assessment the impact of climate change, and we can assessment the impact of climate change on soil moisture too and evapotranspiration. Soil moisture and evapotranspiration depends on a variable of precipitation, and if you more precipitation, more groundwater recharge, of low precipitation, low groundwater recharge. We can see in top figure average temperature in study area, Tripoli area, since 1958, 1988. We can show colors the average monthly temperature across each of the 5 climate divisions of the study area. Climate division shown in yellow, very light colors, and average temperature near 19.6 Celsius in the Janzur area. Red areas were warm or near than 20 Celsius in Al Hadba Al Khadra area. And the bottom figures, we can see average temperature 1989. 20 since 1989, 2019. Colors show the average monthly temperature across each of the 5 climate divisions of the study area. Climatic deviation shown in the yellow, very light colors had average temperature near 20.6 Celsius in Janzur. Red areas were warmer near than 21 Celsius in Al Hadba Al Ghadra. We see increase in average temperature between 1958 and 2019. In this slides, we can see in top figures average precipitation 1958 and 1988. We can note. We can show 351 millimeters in Tajura area and 302.5 millimeters in Janzur area. The minimum the value in Janzur area and the maximum value in Tajura area. And in the bottom figures, we can show average precipitation between 1988 and 2019. The maximum value in the Tajura area was 294 millimeters, and the minimum value in Janzur 256 millimeters. And for this slide, we can show soil moisture in Tripoli area, how to increase by years. In 1958 or between 1958 2019. The maximum values was in Al Garabuli, between 8 and 10 millimeters, and minimum value was in Al Hadba Al Khadra between 6 millimeters and 6 millimeters and 4 millimeters. We can see monthly average reference evapotranspiration between 1958 and 1988. Average monthly reference evapotranspiration varied from less than 125 millimeters in Tripoli to more than 129 millimeters Aswani. We can note in the higher values, the high values in Swani, and the lower values as in Tripoli, because urban area almost included in Tripoli. And agriculture area in Aswani. Monthly average reference evapotranspiration between 1989 2019. Monthly reference evapotranspiration varied from less than 127 millimeters in Tripoli to more than 132 millimeters in Aswani. The same noting Swani is more agricultural lands, and Tripoli is more urban lands. Conclusion: numerical research is presented in this paper for previous studies that have been conducted. This research came to envisage the problem of seawater intrusion in the North Libya. It aimed to determine the hydrodynamic and hydrological behavior of intrusion in the region and to elevate its results by applying simulation models. Since Tripoli is the largest consumer of groundwater in Libya, the city of Tripoli and its hinterland were chosen as the research area. In this way, it is planned to show where the most present intrusion occurs and to investigate it on a close scale. So, such research will not only identify the intrusion measurement in the region and its vicinity, but also predict its future behavior. In this grade, this research hopes to contribute to the clear identification of the coupled machines between field flow and brain dispersion in the Tripolinia region to simulate the transient behavior for the intrusion measurement, and most important of all, its hope to provide valuable information for a future bombing. And the current study shows the significant impact of climate change and increased temperature on decreased precipitation, soil moisture, and increased evapotranspiration in the study area during the period from 1958 to 2019. In addition, it has been possible to identify the areas most vulnerable to climate change impact on the study area when utilizing terra climate data. Remote sensing techniques can contribute to a better understanding of climate change dynamics over time. Nowadays, in semi and dry land, economists mostly are in a great need of strategies and measure for adapting to these challenges. Thank you for listening.
Thank you, Ms. Mubaraka, for your nice presentation. And we have one more speaker, our last speaker of this session, Iftikhar Yassin. But unfortunately, he wasn't able to be with us today. But he showed the courtesy of sharing his video presentation with us. I'm checking, it looks like we don't have any questions at the moment. So I will skip to the Professor Yassin's presentation, which is a pre-recorded video.
Assalamu alaikum everyone. I'm Dr. Iftikhar Yassin from Department of Economics, the University of Lahore, Pakistan. First of all, I congratulate the team for organizing such a wonderful conference, and I'm thankful to the Professor Hussein Gauchekis for inviting me to this most phenomenal conference. Here, I'll be talking about the moderating role of ICT in the natural resource rent and environmental damage and access in BRICS economies. And in this study, we have performed a comparative analysis of carbon dioxide emissions and ecological footprints. The rapid deterioration of the global environment is not surprising. In terms of fulfilling and meeting the vital and fundamental needs, the environmental deterioration has become a problem of grave concern for the policymakers. Therefore, the first and the most significant approach for mitigating the anthropogenic climatic changes is the reduction of greenhouse gases emissions, especially carbon dioxide emissions, as carbon emissions comprises of almost around 60% of total greenhouse gases emissions, and human demand on nature, it's the ecological footprints. Since CO2 accounts for the bulk of greenhouse gases emissions, several environmental studies have emphasized the need to restrict the CO2 emissions to accomplish the Sustainable Development Goals and the 27th Conference of Parties targets. For their rapid growth and significant contribution to the world economy, BRICS are of special interest to this research. For instance, BRICS accounts for almost 22% of the global GDP and growing at almost 6.4% per annum. As a result of their rapid economic growth, BRICS countries are now responsible for almost 42% of global carbon dioxide emissions. Here we have presented the data of carbon dioxide emissions and ecological footprints of BRICS economies from 1990 till 2019, and it is visible that it's on the rise. And it's happening when we are intended to cut these environmental damages. Similarly, here is data of ICT, Information Communication Technologies, and GDP per capita of BRICS economies. It is also from 1990 till 2019, and it's also on the rise. So it needs to be investigated whether these things are causing the environmental damage or helping to mitigate the environmental impacts. Similarly, urbanization has also been presented here from 1990 till 2019, and it's also on the rise in case of all the economies. It is the environmental Kuznets curve. This curve simply indicates that there is an inverted U-shaped relationship between the environmental damage and income per capita. So the foremost aim of the study is to probe the information and communication technologies impacts on ecological footprints and carbon emissions, natural resource rent impacts, democracy, and the moderating role of ICT in determining the environmental impact of NRR, natural resource rent. And this study has investigated these impacts from 1990 till 2019 in case of BRICS economies. So despite the incidence of wide range literature on the nexus among the natural resource rent, ICT, democracy, and the environmental damage, there is hardly any updated study which might have investigated the moderating role of ICT in determining the environmental impact of natural resource rent and perform the comparative analysis of carbon emissions and the ecological footprints in case of BRICS nations. So this is the model we have developed to investigate the environmental impacts. The first one is it's the dependent variable, it's environmental damage. It will be further segregated into carbon dioxide emissions and ecological footprints. Here, ecological footprints measure the ecological assets that a given population requires to produce the natural resource it consumes and to absorb its waste, especially the carbon dioxide emissions. And the next one is the GDP per capita and squared GDP per capita. This GDP per capita and squared GDP per capita has been incorporated to capture the environmental Kuznets curve. Next one is the natural resource rent. Then comes the ICT, Information and Communication Technologies. And we have developed this ICT index by incorporating the mobile subscriptions and the internet subscribers. We incorporated principal component analysis to develop this index. Then comes the urbanization. Then here is a democracy index. It's also an index. Actually, there are many different aspects presented by the VDEM dataset, like liberal democracy, deliberative democracy, egalitarian democracy, participatory democracy, and the electoral democracy. So all these different aspects of democracy. So we were intended to capture all of these dimensions of democracy. So all these different aspects can't be simultaneously put in a single model because of the multicollinearity issues. So we incorporated principal component analysis again to develop a comprehensive index for the democracy as well. Then it's simply the extension of the previous model. Here in this model, we have incorporated the interaction of ICT and natural resource rent. So we started our analysis by incorporating the cross-sectional dependence techniques. because it is necessary. Whenever there is a panel data, we need to investigate whether there is cross-sectional dependence among the series or not. Because in case of cross-sectional dependence, the ordinary first generation techniques might not be useful. So here we have got the idea by incorporating the Piston 2015 test and the bias corrected scaled LM test that there is a cross-sectional dependence. So if there is a cross-sectional dependence, then the first generation unit root tests might not be useful. They might be misleading. So we have incorporated the second generation unit row test, CYPRUS, and this test has indicated that all the series are stationary at their first difference. So we have moved ahead to the co-integration test. It will help us to understand whether there is a long-run association among the series or not. So we incorporated Patroni and Westerlund, and these both tests are indicating that these series are associated with one another in the long run. They have long-run relationships. So now we have incorporated here the Driscoll-Cray estimation technique, because this Driscoll-Cray estimation actually modify the standard errors to take care of the cross-sectional dependence. So here we have 4 models. First 2 models are about the carbon dioxide emissions. First one and the second one only adds the interaction term. Then the model 3 and model 4, they are about the ecological footprints. That is, here the dependent variable is the ecological footprint. In model 4, we have just added the interaction term to the model 3. So the first 2 variables, GDP per capita and squared GDP per capita, indicated by Y and Y square, indicates that the coefficients of these 2 variables are positive and negative respectively in case of all the models. So it is indication that there is evidence of environmental Kuznets curve incidence in the BRICS economies. The third variable is indicated by NRR. It is the natural resource rent. So the coefficient is positive and significant in case of all the models. It is indicating that if the natural resource rent will continue to rise, it will be further deteriorating the environmental quality by instigating the carbon emissions and increasing the ecological footprints. So the next one is the ICT. It is information communication technologies. Its coefficient is negative and significant in most of the cases except the first model. So we have we have got the idea that information communication technology is also helping to mitigate the environmental impacts. Then comes urbanization. So fortunately, it's indicating that urbanization coefficient is also negative and significant. It might be due to the case that there is a compact city theory, which helps us to understand that in case of urban areas, the populations are more compact or getting compact in these economies. So this is why there is a lower level of ecological footprints whenever the urbanization is on the rise, and due to the technologies, due to the latest technologies, urbanizations, the carbon emissions are also cutting down. Then comes the democracy. So in these economies, in BRICS economies, democracy is helping to curb the environmental damage, as the coefficient in all of the cases is negative and significant. Then here comes the interaction term. The simple explanation is that interaction term has a significant impact. It means explaining its role. It's also negative coefficient, but the interpretation of interaction term can be better explained with the help of contour plots. We have presented these contour plots in the next slides. So this is a contour plot for the interaction of ICT and NRR in model 2. That was whenever there is a carbon emission as a dependent variable. So here on the horizontal axis, there is ICT. On the vertical axis, there is a natural resource rent values. And the colors, darker the color, more severe would be the impact, or greater would be the impact. And the contour lines. As the contour lines are curvature. So this curvature form of the contour lines is indicating that there is interaction between the ICT and the NRR. Because in case of the absence of the interaction, these contour lines would be a straight line. So now how to interpret the interaction term? It is very useful here. This contour plot is helping us to interpret the interaction term in a way that at the lower level of ICT, at the lower level of ICT and the lower level of NRR, the ICT is helping to reduce the environmental damage of natural resource rent. but at the higher level of NRR. If natural resource rent will continue to rise, then at a higher level of natural resource rent, ICT will not be helpful. That is, its environmental friendly impact will be converted to the environmental damaging impact. And similarly, here is a contour plot for interaction of ICT and natural resource rent in case of model 4, whenever the ecological footprint was the dependent variable. And here again, we can see that the contour lines are curvature. So it is indicating that there is an interaction term, there is an interaction association between the ICT and natural resource rent. So it's also indicating that whenever ICT will be rising, and it will be helping to reduce the environmental damage impact of the natural resource rent. So moving towards the conclusion and the policy implication, this study examines the influence of natural resource rent, ICT, urbanization, and democracy on the ecological footprints and carbon emissions of BRICS countries during 1990 till 2019. We incorporated principal component analysis to develop indices for the information communication technologies and the democracy. In this study, cross-sectional dependence, second generation CYPRUS panel unit root analysis, and the Petroni and Westerlund panel co-integration techniques have been incorporated. Finally, the cross-section dependence augmented Driscoll-Cray estimation technique has been incorporated to determine the environmental impact. The verdict of this study has important bearings for the policymakers to address the environmental challenges in the BRICS economies. The ICT and the democracy levels needs to be improved to mitigate the pollution emissions. Natural resource rents needs to keep as low as possible to help to reduce the environmental damage and to get environmental friendly impacts of ICT. Because as it is visible that the higher level of natural resource rent, even ICT is not helping. Thank you so much, everyone. I'm again thankful to the organizers.
Thank you very much, Professor Yasin. Thank you very much to all participants in this session. It was a lovely session and it was lovely meeting you, all of you. This will be the end of this session, end of the third session. We don't have any questions, so we are closing this session and we will be with you shortly after 10 minutes for the next session. Thank you very much for being with us.
Catching a bus.